In this video, I will tell you about the basic difference of centripetal and centrifugal forces. Many of you are very confused in differentiating these forces, and in this video I will demonstrate the difference between these two. Now, first of all, let us suppose that there are two cases. In the first case, there is a man of mass m. You can see this man of mass m. He is attached with a rope and he is rotating in this circle with a constant speed of v. And this rope is attached with the center of the circle also. So due to this rope, the man is rotating with a constant speed. And in this second case, this man is standing on the ground and he is watching a ball which is rotating in the same circle of the same radius about the same center, and again that rope is being connected to that ball and the ball is rotating with a constant speed of v. Now wonder why I have written this non-inertial observer here, because this man is an observer himself and he is observing his motion. So you may wonder that when you are standing on a rotating merry-go-round, then if you don't hold the merry-go-round, then you will fall away from the center of the merry-go-round while it's rotating, because you are experiencing some pull which is pulling you outside the circle, away from the center. But when you are standing on the ground and you are watching some other guy who is standing on that merry-go-round, you are not experiencing that pull on him and neither on you while standing on the ground. So when you are standing on that merry-go-round, then you are a non-inertial observer because you are accelerated. Because let's suppose in the second case, in this case, you can see that this ball is rotating with a constant speed v. Now we all know that when the ball is rotating with a constant speed v, I am writing v is constant, as I am not writing the vector sign over v, which tells that v is speed, and if v is constant then tangential acceleration will be 0. But the direction of the motion is constantly changing, therefore the centripetal acceleration AC will be v square by r. Now this centripetal acceleration is directed towards the center AC, and we know that for this observer, the ball is accelerated and the acceleration of ball is equal to AC, which is equal to v square by r. So for this observer who is inertial frame of reference, because the acceleration of observer is 0, so this observer is a inertial frame of reference, and for this observer this ball is accelerated with the acceleration of v square upon r, and this acceleration is directed towards the center of the circle. So when this man will write the equation of the motion, equation for this ball, equation of forces, then he will say that the tension in the rope acting on this ball will be equal to ma. This tension is responsible for this acceleration, and this tension will also be acting towards the center. So this tension T will be equal to ma. A is v square by r. So this tension, this is the centripetal force, which is always directed towards the center of the circle, and in any circular motion there is a necessary centripetal force which is required for that circular motion. Without that centripetal force, that circular motion is not possible. And you can see the examples that if this ball is rotating with a rope attached to it, and then the tension in this rope is playing the part of the centripetal force, as well as when we say that earth is rotating about sun, then the gravitational pull of the sun towards the center of the sun is pulling the earth, and that gravitational pull of the sun is the centripetal force for the earth to be in the circular motion. And when electron is rotating about the nucleus, then the electrostatic pull of the nucleus on electron, which is acting towards the center of the nucleus, is playing the necessary role of the centripetal force for the circular motion. So for any circular motion, a necessary centripetal force is required, whose value is equal to mv square by r, and the role of that centripetal force can be played by different forces, like the tension in this case, like the electrostatic force in the case of atom in which electron is revolving around the nucleus, like the gravitational force in case of the earth revolving around the sun. So in any circular motion, the role of centripetal force is being played by the different forces, and the magnitude of each centripetal force is equal to mv square by r. So for an observer who is standing on the ground, for an inertial observer, this motion of this ball is accelerated, and hence the acceleration of this ball is towards the center, and its acceleration is v square by r, and the tension in the rope is the centripetal force, which is acting towards the center of the circle, and the word centripetal is itself have the meaning of acting towards the center of the circle. So now when this man is itself rotating in the same circle and its mass is m, then this man is a accelerated observer now, because he is rotating in the circle and its acceleration will be in the direction as shown towards the center. So I am referring this man as a non-inertial observer because its acceleration is not zero. So this man will experience a pseudo force on it towards the opposite direction of the acceleration, and the acceleration is towards the center of the circle. Therefore the pseudo force acting in this man will be away from the center, and this pseudo force F pseudo will be equal to mac, where m is the mass of the man and ac is the acceleration of this man, because pseudo force is equal to m into a, where m is the mass of the object and a is the acceleration of the observer, and in this case the man is itself the object and he is itself the observer, as he is observing himself while rotating in the circle. So this force, which is a pseudo force which is acting away from the center, is having the magnitude F pseudo equal to mac, where ac we all know is equal to v square by r. So this is mv square by r. Now this tension force will be balancing. Now when this man is observing himself, then for the observer, he is the observer for his own motion, then for himself his acceleration will be zero, and net force acting on himself will be zero, because this man is observing himself and he would be at rest for himself. So he will say that the net force acting on him will be zero, and therefore the tension force acting towards the center will be balancing the pseudo force F pseudo, and this F pseudo will be equal to mac, which is also equal to mv square by r. So this tension will be equal to mv square by r. Now you can see that in the both cases the value of tension will be governed by the same equation. But in the case of inertial observer, the acceleration of this ball is not zero, but in the case of the non-inertial observer, who is itself rotating in the circle, the acceleration will be zero and the net force will be zero, which means that the centrifugal force, which we say the centrifugal force, is nothing but the pseudo force which is acting on the rotating object itself when he is observing himself while rotating in the circle. So this is the centrifugal force. So finally I can say that the difference of centripetal and centrifugal forces is just the frame of reference. When some inertial observer is watching a circular motion, then he will not observe any centrifugal force, which is a pseudo force, but when that non-inertial observer is itself rotating in a circle and he is itself observing his own motion, then he will experience a force which is acting in the opposite direction of the centripetal acceleration, that is away from the center of the circle, and that force will be termed as centrifugal force. So centrifugal force will be observed only by the non-inertial observer who is itself rotating in the circle. It is also termed as Coriolis force. And in the both cases, you can see that the tension is acting as a centripetal force for the circular motion. And for any type of circular motion, centripetal force is extremely necessary. Thank you.